Alright everybody, this is Mr. Longo here, and in this video we are going to cover some quadratic application problems. And we're going to use our graphing calculator to do this, so make sure you have yours ready. So we're going to talk about a guy named Dazzling Diver Dan, and what he does is he dives off a 3-meter springboard, which is modeled by the equation y is equal to negative 2.8x squared plus 7.4x plus 3. And in this equation, x represents time in seconds, and y is equal to the height in meters. And what we're going to do is take that function, type it into our graphing calculator, and analyze it to answer these questions. So we're going to find out what his maximum height is, at what time he would be 5 meters above the water, at 2.5 meters above the water, and all sorts of other fun stuff like when he actually enters the water. So the first thing we're going to want to do is type in our y1 negative 2.8x squared plus 7.4x plus 3. And for right now, that's all we need. We will need to change and add some stuff into y2 in a little bit. So this says, what is Dan's maximum height? So if we were to click graph, we have some sort of a crazy looking graph, or yours probably looks like this. Now, what we need to do is sometimes adjust our window so it makes a little bit more sense. So in case you forgot how to do that, what you do is click window. Now, I like to see a little bit of the other side of my axes, but we know we can't go back in time, so I'm going to put an x minimum of a -1. And for our maximum, as you saw, it was pretty short. I'm just going to put a 5, just so we can see. He is going to enter the water, but we're not going to be talking about how far he goes into the water. So I'm just going to change that again to a -1. And it did fit in a graph of 10, so I'll leave it. And if we click graph, now we can see a much nicer looking graph for this problem. Now again, that was optional. You could have just used the original, but this will help us out a little bit. So if we were to plot some points, if you click second table, we can get an idea. Now again, I have a crazy window because I wanted you to see that if you click second window, you can change where your table is starting. So you can go back and start your table at 0, and then when you click second table again, we see that we have 0, 3. So again, I just wanted to show you some different features that your calculator has with the window. So at 1, we're up at 7.6. So that would be 3, 4, 5, 6, and a little bit more. We've got a dot there. And then at 2, we're at 6.6. So we're going to be getting a little bit lower, which means the maximum is probably in between there somewhere. At 3 seconds, we are at 0. So what we're going to need to do now is kind of sketch our graph, and we know it went a little bit above. So we need to go find what that maximum height is. So we take our calculator and we go second calc, go to maximum number 4, and this is where we do left bound, right bound guess. So your calculator is asking you to take your little spider to the left side of where you believe the maximum height is. Right there should be good enough, and you click enter. Now your calculator is asking you for the right bound. So we're going to take it to the right a little bit. And again, click enter. Finally, go to guess at the top, and we're going to get a maximum height or a maximum coordinate of 1.321, comma 7.889. Okay, so that's our maximum. So what we need to do is interpret that and says, what is Dan's maximum height? Our correct answer is 7.889 meters. Always make sure you are labeling your answer, okay? The second question says, at what time would Dan be 5 meters? So remember, meters is y. So we can go to y equals, and in y2 we're going to type a 5. Click graph again, and you can see we have two different intersection points. So at what time is Dan 5 meters above the water? We would just have to take our calculator and press second trace, which is the calculate menu. 5 is intersect, and we just want to get close to one of those. Now I'll show you what buttons to push for one. We'll just talk about the rest. So you would just click enter 3 times over here. And we see that it's at 2.337 seconds. Okay, so one of the times is at 2.337 seconds. Now you would have to use the same keystrokes, the second, trace, intersect, and you would go back over here and find this intersection. You would find out he was also 5 meters above the water at 0.306 seconds as well. Okay? Now the next question says, at what time would Dan be 2.5 meters above the water? So again, since we're talking about a height, we can go change it in y. So 2.5, if we were to click graph again, our graph would be a little bit lower. And as you can see, this time there's only one answer, because when he starts, he's already 3 meters above the ground. That's how high the springboard is. So if we were to go, we would only have one intersection because we can't go back in time. So again, same keystrokes. Go find the intersection. You will end up with 2.709 seconds. Okay? Now, at what time would Dan splash into the water? That's one more that you can go use your y is equal to. You would just go change y2 to 0 this time, because when he splashes into the water, that means he's 0 meters above it. And again, you could find the intersection, but we already know this one because when we were sketching out our graph, we saw that it was at 3, 0. So when we're at 3, 0, we know that it takes 3 seconds before he splashes into the ground. So again, the first one we were at 5, so we would have this intersection and that intersection. When we wanted to know 2.5 meters, that was down here. That's why we only had 1. And when we're 0, we're down here again. We only have 1 because we can't go back in time. All right, so this next question just tweaks it a little bit and says, what is his height after 2 seconds? So we know it's 2 seconds. Now x is 2 seconds. We can't go change, but we can go look at the table and just go to 2 seconds and see that we're at 6.6. So again, just look at the table, and if you look at the table 2 seconds into it, we're at 6.6. And again, we already graphed that, but we're at 6.6 seconds just using our table. Or I'm sorry, 6.6 meters. That's his height at 2 seconds. And this last one just says, what does the y-intercept represent? Well, that just represents the original height of the springboard. Okay, so it did say that he jumped off, a springboard that's 3 meters off the ground, so it represents the height of the springboard. And of course we know that's 3 meters. So that's it. That's how you use your graphing calculator to analyze a quadratic function, but to answer some questions about it in terms with an application problem. All right, that's it for this video. This is Longo, and I'm out. See you, bye.